for this lesson, we're going to be writing exponential functions from a graph. So the exponential function that you need to know is y is equal to a, which is your initial amount or your y-intercept, times your growth factor, and your growth factor is taken to a power. And that power could represent, depending on what your problem is stating. So let's start working this problem. And I will tell you, I feel the easiest from the table from a graph is actually to make a table. So to solve this, I'm suggesting that you really do make a table. Here is my x and here is my y. Notice my first point is a 0 and a 5. My second point is a 1 and a 15. And my third point is a 2 and a 45. So now I have all the information in front of me. And it's really easy to see that this is going to be my letter A because it is my y-intercept. So I'm going to write y is equal to 5 times. Now we need to go ahead and see how is it increasing? So we go from a 5 to a 15 to a 45. Well, I know that 5 times 3 is 15, and 15 times 3 is 45. So this 3 that we got, and you should get it for all of them, actually is your growth factor. So it is a 3 and just to the x power. This is what your exponential function would look like for this graph. All right, well, let's look at number 2. Again, I totally suggest making a little chart. It doesn't take a lot of time. And so I'm putting my first point down. Oh, I see. This is going to be decreasing. It starts at a 0 and the y is a 42. My second point is y is a 21. For my third point, x is a 2 and y is a 10.5. And then my last order pair, I see that we have 3 and we have 5.25. All right, I know looking at this information right here, this is my graph moved. This is my y-intercept. So this is going to be my letter A. And now I'm looking and I see 42 goes to 21. Well, I know that that's divided by 2, but I could also say times 1/2. And since it is going down, we are going to want to list our growth factor as a number less than 1. So instead of saying divided by 2, I am going to say times 1/2. So 21 times 1/2 is 10.5. All right, we totally have enough now to write our exponential function. Y is equal to 42 was the y-intercept or where we started, times we see that it is a 1/2 growth. So this is actually would be considered a decay to the nth power. So it's just as easy as that. What you must memorize and need to know is this little formula, which it's not too difficult. So let's look at the real life example. The graph represents the number of computers infected by a virus after X hours. Find the number of computers infected after 90 minutes and after 6 hours. So let's go ahead and let's mark our text. We have a number of computers infected and it's X hours. And now they're going to want us to work this problem twice because we need to find out our 90 minutes and after 6 hours, how many computers have gotten this virus. So again, you know that I'm going to suggest that we go ahead and we write a table to go along with this. And I'm just going to put my table right below the graph. So I have my X and my Y. We see that X starts out at a 0 and Y is 1. We then see that it goes from a 1 to a 4 is the second point. The next point goes from a 2 and a 16. I'm just writing down my ordered pairs, and 3 and 64. Just in case you're not sure, remember, this is always X and this is always Y, and that's how I filled in my chart. All right, well, we can see, again, that our initial, we start with really one computer, just one, and that's going to be our letter A. And then notice, I go from 1 to 4, and then from 4 to 16, and 16 to 64. Well, each one of those, 1 times 4 is 4, 4 times 4 is 16, 16 times 4 is 64. So I know that my growth factor, and it is growing fast, is going to be a 4. So our exponential function is going to be y equals our 1 times, and that is 4 to, it says x, and it's really important. I'm writing this word because we're going to have to do something with it. It's x hours, okay, in hours. So the reason I stress that is because now we're going to use this function, and we're going to find 90 minutes, and then we will find 6 hours. So for that 90 minutes, we need to convert that to how many hours is that? And that's actually 1.5 hours. That's important because we are going to use this number, not the 90. All right, well, let's find the first one. So y is equal to 1 times 4, and it's 1.5 hours. So we know that we're going to do this first, and then we're actually going to have our answer because we're just multiplying it by 1. So y is equal to, when you do that, 8. So after 1.5 hours, and this was hours in case you are having trouble reading that, after 1.5 hours, 8 computers now are down. All right, now, let's see what is going to happen after 6 hours. So I'm going to use the same equation, 1 times 4, but instead of putting 1.5, I will put a 6 there. And now we're going to find out how many computers now have the virus, and it has really grown. It's 4,096, and that is computers with the virus. So hopefully you see that it really makes your life easy when you have a graph to make a table, find the information you need, and then just write the exponential function. If this video was helpful to you today, please add a like, comment, and most importantly, subscribe for more Math with Marcia. See you again soon.